There's one thing more we have to do in order to hook up the contracts we wrote, the mint token contract and the monitor contract, to the PAB. So for that purpose I created this module week 6 PAB, and I am defining a data type called token contracts. So this will represent everything that the PAB can do. So it will define which contracts that PAB will expose. So I choose a data type with two constructors for our two contracts. So one I call mint, and as parameter it takes the token params that we need in order to run our mint token contract. And the other one I call monitor, and as parameter address, because we need an address to run this monitor contract. So we need a bunch of type class instances for this, but we can derive all of them automatically, so we don't have to write any code. Then we need this pretty instance, but we can just use via show, whatever that means. I just copied that from an example. And then, most importantly, we have to write an instance for class has definitions. And that has three methods. One is called get definitions, and it's a list of values of this type here, of token contracts. I'm not exactly sure what that is good for, but we will see later that this is reflected in the Swagger UI that the PAB provides. So I think it's like examples of usage or something like that. So I just use one value that uses the mint constructor and one value that uses the monitor constructor. And for those, of course, I need values of type token params and address. And in order to get those, I just define some sample values here. So as address, I just use the address of the mock wallet 1, same as in the trace I showed you. And then as example token params, I use this address as well. And then as amount 123456 and as token name PPP, as we also used in the CLI example. So get contract tells us which contract should run given a value of this type. So if we get the mint constructor with the TP parameter of type token params, then we want to run our mint token contract with those parameters. Again, as in the trace, I have to specify the W and the S parameters, so I specialize them to unit and empty. And I have to wrap this into the some built-in constructor. And for monitor, similar. So if I see the value monitor address, I will run the contract monitor with address as parameter, and again wrapped in this some built-in constructor. Finally, I must provide the schemas for values of this type. And that's easy because in both cases I have the empty schema. So I could actually have simplified that because it's always the empty schema, and I could have written get schema equals const like this. Okay, and that's all in order to hook up the PAB. Now I can actually write an application that starts the PAB with these contracts. So that's in app token PAB. And that's very simple. I just forgot to delete stuff here. So all it does, it calls run with, which comes from Plutus PAB run. And I just have to specify which contracts. So there's something called handle built-in, and I specialize that to the token contracts type. And that's all. So now we have an executable that will start the PAB, and it will be specialized to these contracts. So it will allow us to start the mint token contract, and it will allow us to start the monitor contract. However, for this to work, we first have to start a bunch of other applications, as was also alluded to in the diagram I showed you when I talked about the deployment scenarios. So we already have a node running, and in addition, we need a wallet and the chain index. And for me to set that up, I was following the README in this folder here. So that's the Plutus apps repo, where the PAB is a part of. And then there's a test node folder, and there's this README file. So they have a test there that sets up the PAB for a specific contract. So it's very similar to what we want to achieve here. So I basically just followed these steps, and it explains how to start a node, how to start the wallet, how to fund the wallet, how to start chain index, and then eventually start the PAB, and then try something. So let's do this now step by step. So the node is already running. The next step is the wallet. When we are in the Nix shell, Cardano wallet is available as a command, so I don't have to do anything to install the wallet separately. So it's just available. And so I wrote a little script called start testnet wallet, which simply calls Cardano wallet with the serve command, and it specifies the network and the node socket. And it uses this config file. And I got the config files that I needed also from the Plutus apps folder, this test node folder that I showed you. So that's the first step. We start a wallet. I have already running mine, and it also takes a bit to sync, although that's relatively fast. So it's much faster than syncing the node or the chain index. The next step is to actually create a wallet now that the wallet backend server is running. So there's a Cardano wallet recovery phrase generate command, which will generate a recovery phrase, and then we must put this recovery phrase in a certain format into a file, and then tell the wallet backend to load the wallet that's represented by this file. So you can do that manually, and that's the way it's explained in this README file that I showed you. But I also wrote a little shell script to do that. So that takes the name of the wallet, the passphrase, and the file name where to write it. And let's see. Let's try this out. Let's call it my wallet. Passphrase, my secret passphrase. And the file, let's call it wallet.json. And now we can look at this generated file. And here is this passphrase, or the 20, sorry, not the passphrase. The passphrase is my secret passphrase. Here is the recovery phrase. And actually you can now use this recovery phrase if you want and import this into your Daedalus wallet or your Yoroi wallet. I did this previously, and I actually linked up my Yoroi wallet to the wallet I created in this way. And then the next step would be to actually fund that wallet. So you can either send funds from another wallet to the new one, or you can use the faucet, the testnet faucet, to fund the wallet. Now you have to inform the wallet backend about your new wallet. And I also wrote a script for that. It's called load wallet, and it uses curl. So the wallet backend also has an HTTP interface, an HTTP API, so you can talk to it via curl, for example, or any other application that can address HTTP endpoints. So by sending this post request here, you can inform it about the wallet, and the request body is this JSON that we just created. So in my case, the file where my JSON representing the wallet is saved is in testnet/restore-wallet.json. So if we do this, then from this point on, the wallet backend knows about the wallet. So here we see this message here. Sorry, it's moving so fast, but somewhere here it says chain following started. So that means that now the wallet backend will follow this wallet on the chain and keep track of all the funds that move to and from that wallet. And we see it's syncing quite fast, so it's already 12% synced at this point. And another important piece of information we get here in response to our load wallet, and that's the wallet ID. So somewhere here, we have the wallet ID. And the wallet ID we need all the time when we talk to the PAB, because we always have to specify for which wallet we do something. And for that, we always need this wallet ID. And if you recall, I created this env file to set a couple of environment variables. And one of them is this wallet ID. Next, we can start the chain index. I also provided a script for that called start testnet chain index. And it's very simple. It just executes Plutus chain index with a configuration file that I also took from this test node directory that I showed you earlier. I've started the chain index already, and the chain index really takes a long time to synchronize, maybe even longer than the node, or at least a comparable time. So that will take a while for you if you haven't done it before. I slightly changed the configuration file from what I found there in the Plutus apps repo, because there it was using a database that was temporary. So each time you switch off your computer and then restart the chain index, it had to resynchronize from Genesis again. So I changed that so that the database file for the chain index is now also in this testnet folder. So it doesn't have to synchronize over and over again, but only from the point where you last stopped it. And finally, we are in a position to start the PAB, so namely this token minus PAB program that I showed you earlier. Recall that's the one that's specialized to the token contracts. And we can do that with cabal run, and it gets a configuration file, and it's told to start a web server. And it also gets the passphrase of the wallet. So this passphrase is the passphrase of my wallet. When you do it, of course, you have to change that for your own passphrase that you chose when you created the wallet. Let's have a brief look at this configuration file, because I want to show you something here. So most of that I simply copied from the Plutus apps folder. But here at the end, there's this pub resume from. And originally it had this tag pointed Genesis, which I think means that if you start the pub, it starts at Genesis. But you can change that and point it to a specific block. And then it synchronizes much faster. Otherwise, synchronizing the pub also takes a long time. So we can do this now because it's been a while since I last did that. So if we go to the node, so this is the node running, you always see these log messages chain extended, new tip, and then the ID of the node and the slot. So I can just take the last one and I can change that here to this ID of the block. And I can do the same for the slot. So I copy the corresponding slot and paste it in here. And now the PAB will start up very quickly because it will start synchronizing from this specified block here, which is the most recent one. Of course, then every now and again you should update this, because now if you, for example, wait a day, then it already takes like 2 minutes or so to synchronize. If we start fresh, so if there is no database yet, before we can start the PAB, we first have to migrate the database. And there's also a script for that. It's called migrate PAB. And it uses the same program that we created, but with different parameters. So it says migrate instead of web server. So let's do this. So we migrate. And now we start. And we see in the time of recording, I mean, earlier you saw me taking the most recent block and putting in the config file that synchronization should start there. But since then, there have already been like 10 more blocks. So it took a little bit to synchronize, but of course it was very fast. And we see that the PAB is available on port 9080. And if you go to this address, so on localhost 9080, and then to swagger/swagger-ui, then you get a nice Swagger interface of this server. And we can try to go through the various operations that are available. So it's actually quite nice. So for example, here we have these definitions where I told you earlier that I just made up some example token parameters, and we can try this. And then we see this. And so this is a serialized format, JSON format form of these parameters I provided. So here we have the monitor where it's just an address. So this is how the address is represented. And here we have the mint contract, and this is the token parameters in JSON format. And it's exactly those that I specified there. So recall, for example, for token amount, I picked 1, 2, 3, 4, 5, 6, and for token name PPP. So this is that. Okay. We see here, for example, that's a very useful one that shows us all running contract instances. But at the moment, there is nothing. So we get an empty list. And in order to start doing something, we need this activate endpoint. This basically takes the wallet for which we are doing this. So this is one example where one needs the wallet ID, and then it needs the parameters. So for example, mint, and then these token parameters. So by calling that, we can start a contract on the PAB. So in particular, it could do the minting or the monitoring. And what is really nice about this is that you could even try it out right here in the browser. So you could fill this in and then press execute, and then this would actually be done. So you could start the contract right from here, from this Swagger web interface. And there are other things, for example, calling an endpoint, which I won't demonstrate because both our contracts are without endpoints. And you can, once an instance is running, you can inspect them here. And what's also nice, if I press execute, then in this case, because I haven't given sensible values here, it will fail, so I get a bad request error. But I do see the curl command that I have to execute to do this. So I can in principle just copy this into a script and then just fill in the fields that I want to correspond to the parameters that I actually want to use. And I have done just that. So I took this curl command and put it in a script file, and now I want to use that to mint tokens by activating this contract. So the idea is I give the amount and the token name and then do the appropriate curl. So one thing I need for this is an address, the address where the freshly minted tokens should be sent to, and also the change. So I need an address for the wallet. One way is to actually import the wallet into Yoroi or Daedalus and then use that. So for example, by pressing receive, then you get an address for the wallet. Another way is to use the wallet backend directly, and that's what I've done. So there's another script, get address, and that's another curl to the wallet backend. And here it uses this wallet ID again. So when we do this, execute it, then we get a long list of potential wallet addresses, and we can just pick one. And I did that and picked one, and I also wrote it into this env.shell file to set the environment variables. So I found this address here by doing this for my wallet and then just picking one. So we know where we get the address from. But in order to give this JSON expression for the token parameters, we need to present the address not in this string form that we just saw as the result of this get address script, but we must give it in this Plutus form where the payment part and the staking part are separated. And I showed you earlier that I have these helper functions that can extract the payment PAB key hash and the stake key hash from an address. And I use these functions, turned them into applications as well, so little tools that I call payment key hash and stake key hash. So they are also defined in the Cabal file, and so I created little executables for those that actually use these functions. And here I'm executing those. So I have my address, and then I use the payment key hash tool with the address as parameter to get the payment part, and then the stake key hash tool with the address as parameter to get the staking part. So now I have all the pieces I need, and I can do this curl and just put the things at the appropriate positions. So here I must put the wallet ID, here the token name, the payment part, the staking part of the address, and here the amount. So if I execute this, then that should work, and we should be able to mint tokens for our wallet. Before we try this, I just want to show my Yoroi wallet. So I called it PPP1. So that's linked up to the wallet that I created using the method I showed you. And right now there are 978 ADA in there and no other assets. Now I can try this command, mint token curl, and amount I choose again 123456 and as token name PPP. So that looks promising. Let's switch back to Yoroi. We have to wait. And now something changed. So now we have assets. Let's click here. And we see we have indeed 1, 2, 3, 4, 5, 6 of some asset. And here we see the PPP. You can also click on that. And then we go to Cardano scan and see information about that. Here we also see the 505050, the hexadecimal representation of the token in PPP that we needed for the Cardano CLI. So that works. We can also go back to Swagger and now check the instances. So let's just execute this. And now we see lots of information there. So we see that for this instance, this wallet, we see log messages. Those are the ones that I specified in my contract. And also some that are automatically generated by the PAB. So for example, we see the transactions that were actually executed. So now we have achieved what we earlier achieved with the CLI with the PAB, minting tokens. And there are pros and cons for both methods, of course. I mean, what is nice about the CLI method is that you only need a node. So you don't need the wallet backend, you don't need the chain index, and you don't need the PAB. But what is not so nice about it is that everything is text-based, and we have to work quite hard to convert all the data types and get the correct values to fill in. And what's also not nice is that we manually had to look up UTXO that we can use as input so that we can successfully mint. So using the contract monad and the PAB, that was taken care of automatically. So we had to specify less in the script here. all I had to do was give the amount and the token name. I also want to show you a third way, namely not doing it by curl, but doing it by Haskell. So I have another tool, so that's called mint token, so a Haskell function. And here I'm using a Haskell library from Hackage called REQ, R-E-Q, which is a simple HTTP client library. So basically, instead of using curl, I can use Haskell. And here is the request. And if you recall, we still had to work quite hard for the PAB in order to get to this JSON representation that we have to present as the request body for our post request. If I use Haskell, that's much easier. So the way this program here works is it takes 4 parameters: the amount, the token name, the wallet ID, and the address. Then I have to pass them into the appropriate types. So that's also in this utils module. So there I have something called unsafe read wallet ID. So that converts this string into an actual wallet ID. And I have something unsafe read address that takes an address and converts it into an actual address. So I simply define my TP, my token parameters, with token, amount, and address. And then I call this min token function here. And that just takes valid ID token parameters. And then I can do my HTTP request like this. So this comes from this REQ module. So I say it's post, I specify the path, which is also quite nice, the syntax here. Then I give the request body by simply using another helper function that's also in this utils module. So let's look at that, but that's very simple. This is here, so given a wallet ID and something of type A, I get so-called contract activation args A. That is exactly what this endpoint expects. So, and this is just a red dog type that has 2 fields. So this A is this CRAD field, and then it needs the wallet. So given the wallet ID, I can make a wallet out of that and specify that there as well. If we look back at this activate, this is the type that's expected here. So here we see this CAID, and here we see the CA wallet. So I use that here to construct my JSON request body. I say that I'm expecting JSON response, that it's on port 9080. So then this response is V. I can extract the status code. So 200 means everything went well. So if it's not 200, I throw an exception. And if it's 200, I return the response body, which will now be of the appropriate type. So of type contract instance ID. So that's the instance ID of the instance of the contract that I have tried to start. I created yet another shell script called mint token Haskell. So that's now the third one. We had mint token CLI, mint token curl, so now mint token Haskell, which uses this Haskell application mint token that we just looked at. And it takes as command line parameters the amount and the token name, as our curl script did. And it fills in the wallet ID and the address from these environment variables. So let's try that out. So mint token Haskell. I don't know, let's say 1 million gold. It also looks promising. Let's check in Yoroi. And there we see our gold. So that also worked. Finally, I also want to demonstrate the monitor contract, but I first want to stop the PAB and clear the database. So that's this file, and then do the migration again to set up an empty database and restart the PAB. And the reason I'm doing that is because we have so many log messages already when we look at the Swagger UI that it gets a bit confusing. So I want to remove everything that we have done so far and start with a clean slate. Now for the monitor, I didn't write a curl version, just a Haskell version, because it's a bit more complicated to extract this status. Remember this observable state where we wrote the wallet at the address. But let's first not look at that, but only at activating the contract. So that is similar to how we did the minting, just simpler because the parameter is simpler. So I expect two command line arguments, just the wallet ID and the address. And as before, I pass them from strings into the appropriate types. And then I call the start monitor function. And the start monitor function is very similar to the min token function that we saw in the other Haskell application. So I just do this activation request post to the same endpoint as before, the activate endpoint. Now my request body, of course, is different. So I use this helper function contract activation args again with the wallet ID, but now the argument is not mint token parameters, but monitor address instead. I again expect a JSON response, and it's again port 9080. I again check whether the status is 200, and I return this response body of the response, which is the contract instance ID. This time I actually need it, because in contrast to the minting, this is a long-running contract. The minting just does the minting, submits one transaction, and then stops. But this one, this monitor one, runs forever. And in order to get to the observable state, I need my hands on this instance ID. Therefore, now I actually need this. But let's now not worry about this part, about the monitoring part. Let's first just start it. So again, I have wrapped this into a shell script because the two parameters, wallet ID and address, I have in my environment variables. And let's just execute this. When I try this out, it starts the monitor process, and it should now start reporting the value. And this is weird, because all these tokens here, those were created by me when I was preparing this lecture, and then I sent them elsewhere because I wanted to start with a clean wallet that only holds ADA. So for the life of me, I have no idea why they are suddenly displayed again, because they are no longer in the wallet. If you check in your ROI, which we did, then only the two that we minted were there, the PPP and the gold. The PPP is here and the gold is here, so far so good, but all the others should be gone. So I have no idea why that is happening. So one suspicion would be that something with the chain index is wrong, that it's somewhat confused and doesn't realize that some of the UTXOs that were sitting at that address in the past have in the meantime been spent. Nevertheless, even though this doesn't work as expected, I want to have a look at the Swagger UI, and there at these instances. So that was the activate. Here's the instances. So if I execute this, here I also get all of these. But what I wanted to show you in particular is here we now have this observable state, and this now holds the value, and it also holds all these weird artifacts from the past. And I also wanted to show how I extract them from Haskell. So this is this function get monitor state. So I, in this case, do a get request, and the endpoint is now API contract instance, and now I need the instance ID, which I got when I started the monitor. So I just have to convert it into a string. That's another helper function that I wrote, and pack it into text, because this, even though it looks like string literals, it uses this overloaded string extension to convert it to text. So this rec library expects text here. So the PEG converts a string to a text. And then status. So I don't need a request body. So everything is just here in the API, in the URL path. And JSON response. And I return this response body. And this is of type contract instance client state token contracts. So this doesn't just contain the observable state, it contains other stuff as well. And because of that, I wrote this helper function observe value here, which takes such a beast and returns a maybe value. And in order to do that, I need to access the field CIC current state of this contract instance client state. That in turn has a field called observable state, which is JSON. And then I use a function from the ASON library, which is the standard library in Haskell to deal with JSON, to pass that into the type I'm expecting, which is this last value. So I get the last maybe value and I return that. Okay, and then in my main program, just to show this, so after I've started the monitor, I enter this recursive loop where I always call go, and I use this get monitor state that I showed, then this observed value to extract the maybe value from there, and I always remember the previous value, and if the new value differs from the previous one, then I write that to the screen. And in any case, I wait a second and then recurse. So this should every second check the value at this address, and if it has changed, it should print the new value. And in principle it works. I mean, the values do make sense and our gold and our PPP is there, but for whatever reason these old UTXOs are also still there. So as I said, my suspicion is it's some problem with the chain index, but I'm not completely sure.